as I read this, it says a woman deposited $1,500 at the end of each month into an annuity. As soon as I see annuity, I'm pulling out the annuity formula. So here's our annuity formula. A is the amount in the annuity after what? After T number of years at this interest rate, compounded monthly because we're doing it every month. And R, okay, so R, that's going to be the amount that you put in at the end of each month or each time period. Now, sometimes R, we use R because it's called the rent. But you know, you could use any money you want here, or even future value here, and then A for amount here. So let's substitute our values into this formula. So A, the amount in this annuity is going to be, okay, this fraction, R, we're putting in what, 1,500 at the end of every month. And then what, quantity 1 plus 0.06 at 6% every month, 12. 12 times, now we're doing this for how long? 35 years. Career minus 1, all that over 0.06 divided by 12. So on my calculator, I'm going to do it like this. Now I've got a fraction, so I'm going to start the numerator with parentheses. So I'm going to type this in like this. Parentheses, that'll start the numerator. And then 1,500 parentheses. Now that parentheses right there is that square bracket, right? Don't put square brackets into your calculator. This one here, that starts the numerator. This one starts that square bracket. Now I need one for this one. So lots of parentheses here. So this is going to be parentheses and then 1 plus 0.06 divided by 12, close, raised to the 12 times 35, close that one. Let's keep our parentheses straight. I got those together. Those go together. Now it's 1,500 times what? Look back over here. It's 1,500 times all of this. So I need that minus 1 to be multiplied by the 1,500. 1,500 times, okay, let's put in a minus 1. And now we'll close, right? So that 1,500 multiplies all of that. And then I'm going to close the top off, right? That one closes this one. And then I'm going to divide, right? Let's divide, right? There's our division. Divide by, now parentheses, because I have an operation in here. If I have an operation, I need parentheses. So divide by what? 0.06 divided by 12. And those match. Okay, you need that set of parentheses around the bottom because you're dividing by that operation. All right, and when I did that, I got the amount. All right, after 35 years at $1,500 at the end of each month at 6%, let's see, she's going to have this much money right here, $2,137,065. All right, so that's interesting. Now, what if we had just done this? So just out of curiosity, what if we had done this? Takes her $1,500, puts it in a box at the end of every month, does that for a year. That's how much you'd have after 12 years, and then multiply that by 35. So 1,500 a month for 12 months. That's a year. And then for 35 years, how much would she have? Okay, well that turns out to be, if I can get it to right here, $630,000. And then just to make a comparison, how does 630,000 and 2,137,000 compare? All right, so here's what we could do. We can compare like this. If we take 2,137,065, divide it by 630,000, that's equal to, that's about 3.39, you know, it's really about 3.4. And then what that says is that $2,137,065 is about 3.4 times as much as 630,000. So if she just puts this 1,500 in a box or in a non-interest bearing account at the end of every month, leaves it there and keeps doing it for 35 years, she'd have 630,000. But if she invests it and can get a guaranteed investment at 6% compounded monthly, she's going to make about 3.4 times as much money.